Hey everyone, welcome back, or if you're just joining us, welcome to KSSP Podcast. I'm Spencer.
I'm Katie. Today we're going to be talking about hallucinogens and psychedelics. Now, in tomorrow's episode, we're going to specifically go over MDMA. I did just want to mention that it is technically part of this category, but that will be its own episode for later on today. So we'll go over a couple of pictures here. This is from Pharmacological Reviews. So psychedelics tend to increase neuroplasticity, dendritic spines formation and growth, axon branching synapse formation, and then it tends to decrease anxiety, depression, and PTSD. So we have ayahuasca, DMT, and 5-MeO DMT, which activate the mTOR, BDNF, TRKB, NGF, ERK1, ERK2, CREB, CAMK2, the 5-HT2, AR, and AKT. Then ketamine activates the mTOR, BDNF, TRKB, and the AKT. DOI activates the EGR1, EGR2, CFOS, and EGR3. And then LSD activates the mTOR, EGR1, the CEB, PB, the SGK, NEA3, DHEA, CFOS, EGR2, IKB, NOR1, MKP1, and DHEA. I don't know why DHEA is listed twice, but it is, I guess. And then psilocybin or mushrooms activate the mTOR and the BDNF. Then MDMA, which we'll talk about later, that will be activating the cortisol, prolactin, and oxytocin. And then our next image here is from drugrehab.com. This is the effects of hallucinogenic drugs on perception. So basically, this is just showing our senses connecting neurologically. Here, thinks you hear sound, you think you feel a sensation, think it smells a scent, and you think you see something. So these are the effects of the hallucinogenic drugs on perception. Experts think the drugs cause hallucinations by disrupting communication between chemical systems in the brain and spinal cord. These areas of the nervous system are in charge of sensory perception. In the typical route of administration, so I'm just going to go over LSD and mushrooms. LSD is usually a sublingual, meaning that it dissolves in your mouth. And with mushrooms, you typically eat them or you can drink them as a tea as well.
And then we'll go into, again, just some kind of pharmacology. And we'll have three kind of different ones for this one. So we'll start with dissociatives, the classical dissociatives. So classical dissociatives achieve their effect by blocking binding of the neurotransmitter glutamate to NMDA receptors. So NMDA receptor antagonism. They include ketamine, methoxetamine, or MXE, phencyclidine, or PCP, dextromethorphan, DXM, and nitrous oxide. Dissociation is also remarkably administered by salvinorin A, which is the active constituent in Salvia divinorum, shown, I guess, to the left. Not with us, but where I got this from. And potent K opioid receptor agonism, though usually described as a very atypical dissociative. Some dissociatives can have CNS depressant effects. They process pain as a kind of far-away sensation. Pain, although present, becomes a disembodied experience, and there is much less emotion associated with it. So these are just some little effects of the ones that we just mentioned. So like DXM in higher doses can increase heart rate and blood pressure and still depress respiration. Nitrous oxide, the principal risk with that one seems to be due to oxygen deprivation, and injury from falling is also a danger, as nitrous oxide may have caused sudden loss of consciousness in effective oxygen deprivation. And then because of the high level of physical activity and relative imperviousness to pain induced by PCP, some deaths have been reported due to the release of myoglobin from ruptured muscle cells. High amounts of myoglobin can induce renal shutdown.
We are going to talk about PCP in a later episode a little bit more as well.
Yes. And then we'll move on to deliriants. So, despite the full legal status of several common deliriant plants, deliriants are largely unpopular as recreational drugs due to the severe, generally unpleasant, and often dangerous nature of the hallucinogenic effects produced. Typical or classical deliriants are those which block the muscarinic acetylcholine receptors, so again, antagonism. These are said to be anticholinergic. Many of the compounds are produced naturally by plant genera belonging to the nightshade family Solanaceae, such as Datura, Brugmansia, and Latua in the New World, and Atropa, Hyoscyamus, and Mandragora in the Old World. These tropane alkaloids are poisonous and can cause death due to tachycardia, induced heart failure, and hyperthermia, even in small doses. Additionally, over-the-counter antihistamines such as diphenhydramine, brand name Benadryl, and dimenhydrinate, brand name Dramamine, also have an anticholinergic effect. Uncured tobacco is also a deliriant due to its intoxicatingly high levels of nicotine. And then psychedelics. So while the method of action of psychedelics is not fully understood, they have shown affinities for various 5-HT serotonin receptors. They may be classified by their activity at different 5-HT subtypes, particularly 5-HT1A, 5-HT2A, and 5-HT2C. They produce their effect by acting as strong partial agonists at the 5-HT2A receptors. How this ends up producing the psychedelic experience is unclear. It's likely that it acts by increasing excitation in the cortex, possibly by specifically facilitating input from the thalamus, the major relay for sensory information input to the cortex. Researchers discovered that many psychedelics are potent psychoplastogens, compounds capable of promoting rapid and sustained neuroplasticity. So then we have tryptamine, along with other trace amines, is hypothesized to play a role as a neuromodulator on classical monoamine neurotransmitters such as dopamine, serotonin, and norepinephrine. Non-selective serotonin receptor agonists to activate serotonin receptors, and a serotonin norepinephrine dopamine releasing agent, SNDRA, to release more monoamine neurotransmitter with a preference for evoking serotonin and dopamine release over norepinephrine release. Psychedelic tryptamines found in nature include psilocybin DMT, 5-MeO-DMT, and tryptamines that have been synthesized in the laboratory include 4-HOMET, 4-HOMIPT, and 5-MeO-DALT. And then phenethylamine is also a trace amine. It acts as a neurotransmitter in the human central nervous system. It regulates monoamine neurotransmission by binding to trace amine associated receptor 1, or TAR1, which plays a significant role in regulating neurotransmission in dopamine, norepinephrine, and serotonin neurons in the CNS, and inhibiting vesicular monoamine transporter 2, or VMAT2, in monoamine neurons. When VMAT2 is inhibited, monoamine neurotransmitters cannot be released into the synapse via typical release mechanisms. Mescaline is a naturally occurring psychedelic. protoalkaloid of the substituted phenethylamine class. And then amides of lysergenic acid are collectively known as lysergamides. And there are a number of compounds with potent agonist and or antagonist activity at various serotonin and dopamine receptors. LSD, lysergic acid diethylamide, is one of the many lysergamides. 1P LSD is a derivative and functional analog of LSD and a homolog of ALD-52.
Yeah, so now we've got another article from the National Institute of Health again, and so we've got the specific short-term effects of a few psychedelics here. So for LSD, there's increased blood pressure, heart rate, and body temperature, dizziness and sleepiness, loss of appetite, dry mouth and sweating, numbness, weakness and tremors, impulsiveness, and rapid emotional shifts that can range from fear to euphoria, with transitions so rapid that the user may seem to experience several emotions simultaneously. And then with psilocybin, there's feelings of relaxation, similar to effects of low doses of marijuana. There's nervousness, paranoia, and panic reactions that can happen, introspective and spiritual experience, which I think also applies to like pretty much any of these. I don't know why it's only on that specifically, but anyways. And then there's a misidentification of poisonous mushrooms resembling psilocybin, and that could lead to unintentional, potentially fatal poisoning. And we've got peyote, so that's going to increase your body temperature and heart rate. You're going to have uncoordinated movements or ataxia, profound sweating and flushing. DMT will increase your heart rate. It might make you agitated, and then these hallucinations frequently involving radically altered environments, as well as body and spatial distortions. Which the body and spatial distortions, again, are true. I mean, I've noticed that for all of them, honestly. That at least the ones I've tried in the past. And then there's ayahuasca, and that's going to increase your blood pressure. You could get severe vomiting induced by the tea, and then a profoundly altered state of awareness and perceptions of otherworldly imagery. So the short-term general effects of hallucinogens, the sensory effects include the hallucinations, and that includes seeing, hearing, touching, or smelling things in a distorted way, or perceiving things that do not exist, which, yeah, I'll talk more about that in our conclusion. Intensified feelings and sensory experiences, including brighter colors and sharper sounds, and mixed senses, which would be like seeing sounds or hearing colors. And then changes in sense or perception of time. Time goes by rather slowly. And then the physical effects include increased energy and heart rate and nausea. And then some long-term effects. Persistent psychosis is possible. It's pretty rare, but it is possible. It includes visual disturbances, disorganized thinking, paranoia, and mood disturbances. And then there's also another rare disorder, the hallucinogen persisting perception disorder, HPPD, which includes hallucinations, and this is after the drugs worn off, so this is long term. So hallucinations, other visual disturbances, such as seeing halos or trails attached to moving objects, and then symptoms sometimes mistaken for neurological disorders, such as a stroke or a brain tumor. So that's what the NIH has to say about that. And then our final article for today is about psychedelic-induced neuroplasticity from nature.com. This is from a study. So I'm just going to read a couple parts here. So in this study, firstly, they review the evidence that psychedelics promote neuroplasticity and examine the cellular and molecular mechanisms beyond the effect of different psychedelics or on different aspects of neuroplasticity, including dendritogenesis, synaptogenesis, neurogenesis, and expression of plasticity-related genes. So, for example, brain-derived neurotrophic factor and immediate early genes. And then next, they examine where in the brain psychedelics promote neuroplasticity, particularly discussing the prefrontal cortex and the hippocampus. Then they also examine what doses are required to produce this effect. So, for example, hallucinogenic doses versus microdoses, and how long purported changes in neuroplasticity last. And then finally, they also discuss the likely consequences of psychedelics' effects on neuroplasticity for both patients and healthy people, and they identify important research questions that would further scientific understanding of psychedelics' effects on neuroplasticity and its potential clinical applications. And finally, classic psychedelics are thought to catalyze a period of accelerated neuronal growth, enhancing the brain's capacity for neuroplastic changes. Studies in animals have shown that LSD, psilocybin, DMT, and DOI promote the expression of genes related to synaptic plasticity, including immediate early genes and BDNF. Furthermore, they catalyze a burst of synaptic and dendritic growth and can increase the strength of long-term potentiation. That was our episode on hallucinogens and psychedelics. And in our next episode, we'll be going into depth on MDMA, so you can join us for that.
And as always, you can leave a comment below if you have any topics that you want to hear us talk about in future episodes.
You can reach out to us on Facebook, YouTube, Instagram, Twitter, TikTok, and we also occasionally do live stream on Twitch, so follow us there to be notified.
And don't forget to give this video a like, as well as follow or subscribe to our other social media accounts and turn on notifications so that you get notified when our future content comes out. Otherwise, we will see you all in the next video.